right, this is Unit 2 review, Day 1. Unit 2 was all about logarithms and natural logs and solving and converting and all of that good stuff. So like the first thing we learned was how to convert between logarithmic and exponential form. So like for example, log base 2 of 8 equals 3. Remember, you always start with your base. So to convert this, we're in log, so we need to turn it into exponential form. So that becomes 2 to the third power is equal to 8. And that's the exponential form of that. Now, for example, where I have natural log down here, natural log's base is always e. So that becomes e to the 10th power is equal to x. Okay? Now, remember when you write natural log, you don't ever write the base because it's always understood to be e. You don't ever write anything else. And with log, if it doesn't have a base, it's understood to be 10 for the base. So for number 2, we have e squared equals x. So we need to convert that to natural log form. So that becomes natural log base e, but we don't write it, is equal to, natural log of x. So natural log base e of x is equal to 2. Okay? So that means 4 to the third would become log base 4 of 64 is equal to 3. Okay? So you always do that circle trick. You start with your base and go all the way around to the opposite side of the equal sign and then back around. All right? So then when we want to evaluate log base 4 of 64, remember to use that in your calculator, you would do log of 64 divided by log of 4. So in our calculator, we would do log of 64, make sure you close your parentheses, divided by log of 4, which gives me 3. So 3 is my final answer there. Okay, I'm going to skip 6 and come back to it. With log base 5 of 125, you would do log of 1 over 125 divided by log of 5. Notice I'm always putting the second number on top and then the first number. So log of 1 over 125, close my parentheses, divided by log of 5 gives me negative 3. And the reason why that's true is because 5 to the negative third power gives me that, okay? And 4 to the third power is equal to 64, so that's why we know that's true, okay? So like, for example, log of 32 divided by log of 4. Log 32 divided by log of 4 gives me 2.5. Now, number 6 and number 9 are different. These ones are kind of easy peasy ones because notice when I have the same base as what I'm taking the log of, all of that cancels out, and whatever's left over, which is that 3, is my final answer. And the same thing goes with an exponential. If I have 5 to the log base 5, all of that is going to cancel out, and the 7 is what's going to be left over. So that's my final answer there. So whenever you have the same base as the log, that means that they cancel out. Okay? And then we talked about our log rules with combining, condensing, and expanding and all of that good stuff. So remember, that's when multiplying is the same thing as adding, and dividing is the same thing as subtracting. So when we're condensing, it's going to look like adding and subtracting, and we're going to condense it down to multiplying and dividing. And when it's multiplying and dividing, we're going to expand it out to adding and subtracting. Okay? So like, for example, we want to condense these. We want to combine it into smaller ones. So that means we're going to, because it's adding in between, that means we're going to multiply what we're taking the log of. So it's going to become log of 2x squared y times 5x y squared z. And you always combine like terms if you can. So that becomes log of 2 times 5 is 10. X squared times x is x to the third. Y times y squared is y to the third. And then z doesn't have anything to combine with, so it says z. Okay, you always combine it and simplify if you can. But because we have variables, there's no way to simplify that any farther. So that is the condensed version of that. Okay, So then the next one we have log of 20x to the 6 minus log of 2xy squared. And again, this is the same type of problem as the last one, but because we're subtracting, it's going to turn into a division problem. So that's going to become log of 20x to the 6, whatever comes first is what goes on top, divided by 2xy squared. Okay, and then we simplify. So 20 divided by 2 is 10. So that becomes log of 10 x to the 6 divided by x. I mean, remember when you divide, you subtract your exponent. So that's going to become x to the 5th over y squared. And so that is the simplified version of that one. Okay, so when we added, it turned into a multiply. We multiply whatever's inside the parentheses. When we subtract, we divide whatever's inside the parentheses. So then when we add, we're going to multiply log base 2 of 8 times 16. We're going to continue to simplify. 8 times 16 is 128. And then here you can continue to simplify that. That becomes log of 128 divided by log of 2, which gives me 7. So 7 is the completely simplified version of that. So if it asks you to simplify if possible, you always continue to keep going. If you have a variable, you're not going to be able to continue simplifying. Okay, so then now we're going to do the opposite. We're going to expand it. So here we've got x squared, y, z to the 5th. So they're all being multiplied together. So that means they're all going to get their own separate addition. Now remember, there's one other thing. When we have exponents, they always go to the front. So that's going to become log base 5 of x squared plus log base 5 of y plus log base 5 of z to the 5th. Okay, and now the only other step to expand that even farther is to take all of our exponents and move them to the front of our log. So that becomes 2 log base 5 of x plus log base 5 of y plus 5 log base 5 of z. Okay. So that's an example where they're all being multiplied together, and because they're being multiplied, that means to expand it, it turns into an addition. The only other thing you have to remember is that when you have an exponent, the exponent gets moved to the front. So for our next example, we have log base 4 of x plus 2 to the 3rd divided by x minus 2. And so again, because we're dividing, that means it's going to turn into a subtraction problem. So that's going to become log base 4 of x plus 2 to the 3rd minus log base 4 of x minus 2. And the only thing left to do there is to move our exponent to the front. So that becomes 3 log base 4 of x plus 2 minus log base 4 of x minus 2. And that is our final answer for that one. Okay. And number 15 is very similar to number 14, same way, except for notice my exponent got moved to the bottom. So that's going to become log base 2 of x plus 5. And because we're dividing, it turns into subtraction. Log base 2 of x minus 1 to the 2nd power. And again, my 2 is going to get moved to the front. So my final answer there will be log base 2 of x plus 5 minus 2 log base 2 of x minus 1. And that's my final answer there. Okay, so that's it for the Unit 2 Day 1 review. Okay, for the classwork, you're just practicing what we just talked about. You're going to practice converting between exponential and logarithmic form. And you're going to evaluate like we did. And then you're going to condense for 9 through 11 and expand for 12 through 14. Okay? Again, if you have questions, message me on Remind or comment on the Google Classroom.